Hello, how are you doing? Welcome to a brand new class. This time we are going to be introducing a new topic. From here on and in the next series of videos, we will be covering the automation aspect when managing multiple instances OMniLeads in production. Here's the thing. We were, throughout all the previous videos, showcasing the new version of the application and working at the Docker Compose level. Docker Compose, as we know, is a technology that allows us to orchestrate containers from a file that resides within the Linux server on which we are going to build the application, already speaking a little of the application in production. We have that then, what we were seeing had to do with the fact of entering to the server in question to make an installation. That installation translates into downloading the OMniLeads repository and making some settings at the environment level, which is the file that Docker Compose reads to. Set up all the variables part, and then we have an OMniLeads instance on a Linux server deployed through Docker Compose and the bash script. First boot installer that we were working on and explaining in previous classes. What is the problem with that approach? That when you start to grow the number of OMniLeads instances to manage, it becomes a very manual process for the entire task. This entails an excessive expenditure of time and the possibilities of reproducing human errors increase. Because if one has to make an update on 20 servers, on 20 subscribers, already assuming that we are talking about a company, an enterprise, and an IT professional who is managing them. Well, let's say above a threshold of 10 to 15 instances, it already seems to me that it is a bit untenable. Manage them using the techniques deployed in the previous videos. That is based on Docker Compose 1, remote access by Sausend, where tasks are performed on the instance in question. That's where thinking, again, on the potential that the OMniLeads application has when it comes to offering contact center as a service. And this implies, of course, deploying one instance of OMniLeads per subscriber. So let's imagine already when you start to scale the number of subscribers and therefore the number of OMniLeads instances to manage, it becomes, as we said, quite cumbersome to manage based on Docker Compose and remote access via SSH. That's where we introduced way of using OMniLeads, of deploying it and managing it, which involves using Ansible. Ansible is a technology that is already by now ultra publicized, and it is focused on managing IT infrastructure in an automated fashion, on automating infrastructure management. This allows well for configuration, deployment, and orchestration of multiple servers, especially Linux, in parallel. So one could be standing on this image where we can see that we have a centralized node, which is the deploy manager, which we can call based on Ansible, where from there, from a host inventory, which we are going to see, but basically you declare the address, IP, and the parameters to be able to access via SSH. You declare a list of hosts, and from there, you can perform actions on the different hosts, right? In our case, in the OMniLeads context will be new deployments of OMniLeads or provisioning of update, deploys of backups, for everything that has to do also with configuration, password rotation, etc. The idea is that we can concentrate in a central node the management of all the instances of OMniLeads that we have deployed on the internet. It can be on the internet, or it can be in an infrastructure on premise. The only condition that requires Ansible access. So in essence, we are talking about an agentless technology, meaning there is nothing to install. Each server running Linux simply needs to have the capability of accessing via SSH, so that from this centralized node, we can perform actions on the Linux instances that drive one of the requirements we mentioned is the SSH, but specifically, it involves the fact that this centralized node, this deploy manager, needs to install its SSH public key into each of these instances. Nowadays, we know well that, particularly with cloud providers, one can upload an SSH public key, and then automatically, every time a new server is deployed, a new virtual machine, that public key is already inside. So you don't even have to copy the public key from the deploy manager to the Linux server. So in general terms, we will be able to perform from this centralized node deployment of new instances, the possibility of upgrades or rollbacks, and also to take backups and restores on the servers that we are going to be managing from this centralized node